right, just a quick recap in terms of where we are. We were successful in terms of ingesting the data set. We created the FID project and we collected the fiducial marks. We did a rough nominal georeferencing to do quality assurance to make sure that the images were all properly orientated and everything was looking good, which was fine. Then we moved on to the course alignment and we had a look at the course alignment results, which I'll just load up here really quickly once again. We eliminated a few bad points and we did that using the tool here. So the project overview tool, if I show the ground control points, we have good distribution of our ground control points. We also make sure that there are no images that have no ground control points. So the worst one is this one here, which has 4 ground control points. Overall, our GCP RMS, if we compute the model at this point, is quite acceptable. So I'm just going to automatically compute the model. And if I pull up the residual report, our GCP error is below 10 pixels, and our tie point error is below 1 pixel as well for our project. If I switch that to ground units, at the moment our RMS in terms of meters is about 5 meters, and our tie points is below 1 meter. So that's looking pretty good. So our next step in terms of HAP processing is to once again open up the alignment panel. And this time what we're going to do is we're going to create a fine alignment. So we did the course alignment, we inspected the points, and we saw that we eliminated a few bad points to improve our overall model. As long as we get our overall error down below 20 pixels, then we can move on to the fine alignment stage. So I'm going to select a fine alignment, and in terms of the input folder, I simply need to point to my folder where I ran the course image alignment. So I'll just make sure that's properly selected. So that's the folder I want to use. The elevation model is just up in the reference folder. So I'll pick that. And then the reference file is the reference mosaic from 2004. Now the GCP collection strategy, here's where I can play with some of the parameters. I can actually bring this down to 100. You'll recall that currently the GCP accuracy is below 10 pixels. So I'll bring this down to 100, and I'll keep the RMS a little bit higher at 50. And then the same thing for tie points. I'll bring this down to 100 and I'll bring it down to 50 for the refinement. Now this is just a strategy that you can use. This is one that we found that works quite well. You can obviously keep the search radius larger. Essentially, the larger you make the search radius, the more control points you're going to have. So it's going to mean that you'll have to refine and eliminate bad points down the road. So you have to keep track of how your project is going and ensure that you're parameterizing the project accordingly. So the output data folder, I'm going to use the same folder, and what this will do is it will create a stage 2 folder in here. So let me go ahead and run that. That's going to take a few minutes, so I'll be back in a few minutes. So you can see that the folder has been created, and the HAP software is now going to perform the fine image alignment and try to get us even better model for correcting all of our images. Okay, so as you can see, the processing is completed for the fine alignment step. We were able to run through the data once again. We have this new folder which has been created in our alignment folder, so now it's stage 2. So we can take a look at the results from the stage 2 alignment. We'll open up Ortho Engine and we'll quickly take a look here at what our results are. Go to the GCP panel, pull up our project overview. First thing we'll do is make sure that our GCPs are well distributed. So it looks like they're very nicely distributed, and it looks like there's actually even more than the last time around when we did the course image alignment. We can also pull up the summary table, and I'll just turn on the option to automatically recompute the model as I make changes. So here's our overall project. You can see that now we have way more GCPs. If you recall, in the previous step there was one image that only had 4 GCPs, and now the minimum number of GCPs that I have is 59. If I look at the overall GCP RMS, it looks like it's a bit more consistent. I do have one image here which has very low RMS, but most of them here are in this range. And just in general, if I turn on the tie points as well, I'll just make sure that the tie points look good as well. So I've got quite a few tie points. I can turn off the GCPs just to be able to see the tie points a little bit better. So it looks like everything is nicely tied together. Once again, if you recall from before, I can turn off the multi-way tie points and see what I have. So if I go 2 rays, I've got quite a few images with 2 rays, 3 rays, some even have 4, 5, and it looks like I've got about 5. What I'll do next is I will pull up the residual panel and start to make some changes here. So it looks like things are in need of a little bit of grooming once again. So let me use a different approach this time. I'm going to select points by residual. So I'm going to pick 100 points, and I only want to use 10% of the points per image. So I don't want to eliminate too many points per image. And the residual that I want to get is anything below, let's say, 10 image pixels. So I'm just going to hit select, and automatically what this is doing is it's giving me the GCPs that are meeting that criteria, and I can either delete these or I can change them to checkpoints. So let me change them to checkpoints and see what impact that has. And right away you can see that that improved my RMS to below 7 pixels, and if I switch that to ground units, now I'm in the 3.5 meter range for my ground control points. So things are looking pretty good. So I could keep going in terms of editing this project and trying to get down to 1 pixel for my my accuracy. That would be the case if I wanted to produce very high quality elevation models. So I can still produce elevation models at this point. There might be they might not be as good quality, but definitely I could go ahead and produce elevation models at this point. So I can take the same approach for tie points. What I'm trying to get to is below 1 pixel. So I'm going to select 1 as my lowest selectable residual. I'm going to collect 100 residual points that and only 10 per image. So let me select those, and I'll just go ahead and delete them. Let me turn on the tie points just so we can see that visually as I do it. So I'll hit delete. And I haven't really modified my distribution much, and I've eliminated some bad points there. So this is looking pretty good. At this point, what I'll do is I will run through the fine alignment stage one more time. I'll come back into Ortho Engine, inspect my project, and then we'll move on to the Ortho and Mosaic production stage.